Hello everyone, welcome back to my channel. So in this video we'll solve a problem on electric force and electric field intensity. Okay, if you are first time to my channel, please consider subscribing and hit the bell icon to get notifications from my channel. Right, in this problem he has given two charges of 1 millicoulomb and minus 2 millicoulomb, which are located at these points from origin respectively. Next, he has asked to find the electric force and electric field intensity on 10 nanocoulomb charge, which is located at 031 from the origin. Okay, so this is very simple concept which we can solve from Coulomb's law and electric field intensity concept. Okay, so I have explained those two concepts in my previous two videos. You can see there, okay, and come here again to solve this problem. Right, there is one origin, okay, considered here origin O. So there is a charge, a point charge Q, which is of 10 nanocoulomb, okay, 10 nanocoulomb, which is present at 031, at a point of 031 from the origin. Next, there is another point charge Q1, which is of 1 millicoulomb, which is present at 3, 2, minus 1, and there is another point charge Q2, which is of minus 2 millicoulomb and present at minus 1, 4. Okay, so he has asked you to find the force, total force exerted by Q1 and Q2 on Q. So the total force, as it obeys superposition principle, the total force is given by F1 plus F2, F1 bar plus F2 bar. So F1 is the force of Q1 on Q and F2 is force of Q2 on Q. Right, so the formula is given by Q into Q1 by 4 pi epsilon naught. So I am writing the vector directly. So r minus r1 by modulus of r minus r1 whole cube plus q into q2 r minus r2 divided by 4 pi epsilon naught modulus of r minus r2 whole cube. Okay, so this is what we have to find. This is the total force. Once you find the total force, you can find the electric field intensity. Right, so we have all these values Q1, Q1, 4 pi epsilon naught, everything is there. We have to find r minus r1 and modulus of it. Similarly, r minus r2 and modulus of r minus r2. So I am first finding those values. Okay, so r minus r1. So what is r? R is the distance of the point charge from origin, which is 0, 3, 1. So this r is always point of interest. R is always the point of interest, that is the point where you are finding electric field intensity or force. Okay, minus Q1. Q1 is 3, 2, minus 1. So if you take the difference, it will be minus 3. 3 minus 2 is 1. 1 minus of minus 1 is 2. So if you write in vector form, so r minus r1 is minus 3ax cap plus ay cap plus 2az cap. And if you find the modulus, r minus r1 is root of minus 3 whole square plus 1 square plus 2 square. So it will be root of 14. Right, similarly r minus r2. R minus r2 is 0, 3, 1 minus r2. R2 is minus 1, 4. So 0 minus of minus 1 is 1. 3 minus of minus 1 is 4. 1 minus 4 is minus 3. If you write in vector form, r minus r2 is ax cap plus 4ay cap minus 3az cap. So modulus of r minus r2 is root of 1 square plus 4 square plus minus 3 whole square. So it will be root 26. Okay, so now we have got all the values. We can substitute in this formula. Okay, so F is equal to, so we can take Q by 4 pi epsilon naught common, so it is there in both, so Q by 4 pi epsilon naught I am taking out. Okay, so this will be Q1 is 1 millicoulomb, right? So 1 millicoulomb into R minus R dash. R minus R dash is minus 3AX plus AY cap plus 2AZ cap divided by root 14 whole cube. Okay, so modulus of R minus R1 is root 14, so it is whole cube, plus the Q2 value is minus 2 millicoulomb. So Q I have taken common, so I'm only left over is Q2, so Q2 is minus 2 millicoulomb. R minus R2, R minus R2 is this one, AX cap plus 4AY cap minus 3AZ cap divided by R minus R2. R minus R2 modulus is root 26, so this is root 26 whole cube. Okay, so F bar is equal to, so what is the value of Q? Q value is 10 nanocoulomb, 10 into 10 to the power of minus 9. So we know that 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. 9 into 10 to the power of 9. So this is millicoulomb and this is also millicoulomb charge. So I'm writing it outside, so it will be 10 to the power of minus 3 into, so this 1 is multiplied by this minus 3AX cap, right, plus AY cap plus 2AZ cap divided by root 14 whole cube, right, minus, so millicoulomb I have taken it outside, so this will be minus 2 into AX cap plus 4AY cap minus 3AZ cap divided by root 26 whole cube. Okay, so this 10 to the power of 9 into 10 to the power of 9 gets cancelled off, so this will be 90 into 10 to the power of 3, 90 into 10 to the power of minus 3 into, so minus 3AX by root 14, or just a minute, minus 3 by root 14 whole cube, right, minus 2 by root 26 whole cube into AX cap plus 1 by root 14 whole cube minus 8 by root 26 whole cube into AY cap plus 2 by root 14 whole cube plus 6 by root 26 whole cube into AZ cap. Okay, this is multiplied by 90 into 10 to the power of 3. So if you solve them, so you'll get the answer as minus 6.512 AX cap minus 3.713 AY cap plus 7.509 AZ cap millinewtons. Okay, so 10 to the power of minus 3, take it as it is, so you'll get in millinewtons. So 90 multiplied by this into AX cap, so 90 multiplied by this term, this total term into AX cap will be minus 6.512. So 90 multiplied by this term will be minus 3.713, and 90 multiplied by this total term is your 7.509. Okay, so into 10 to the power of minus 3, so it will be in millinewtons. Okay, so this is how we can find the force. Let me take one more slide and I'll explain you how to find the electric field intensity at the same point. Okay, so just now we have obtained the force as minus 6.512 AX cap, right, minus 3.713 AY cap plus 7.509 AZ cap of millinewtons. Okay, so next we have to find electric field intensity. So what is electric field intensity? It is force per unit charge. Okay, so this unit charge is 10 nanocoulomb charge, which is located at 0, 3, 1. So we have already found the total force. Okay, so total force is this, and if you divide it by the charge, you will get the electric field intensity at that point. Very simple, right? So I am substituting that minus 6.512 AX cap minus 3.713 minus 3.713 AY cap plus 7.509 AZ cap, this into 10 to the power of minus 3, because it is in millinewtons. 10 to the power of minus 3 divided by the charge here is 10 nanocoulomb, so 10 into 10 to the power of minus 9. So this will be minus 6.512 AX cap minus 3.713 AY cap plus 7.509 AZ cap. So this will be 10 to the power of minus 8. If it goes up, it will be 10 to the power of 5, right? 10 to the power of minus 8. So if it goes up, it becomes 10 to the power of 8 into 10 to the power of minus 3 is 10 to the power of 5. So how can we write this? Minus, so E bar is equal to minus 651.2. Okay, so I'm multiplying with 10 square, right? 651.2 minus 371.3 AY cap plus 750.9 AZ cap. So I multiplied with 10 square, so I'm writing here 10 to the power of 3, because already I have taken 10 square inside. Okay, so this is volt per meter. So 10 to the power of 3 can be written as kilovolt. So it will be, so finally it will be minus 651.2, sorry, AX cap here I have forgotten. So AX cap minus 371.3 AY cap plus 750.9 AZ cap kilovolt per meter. Okay, so this is how we can find the force exerted by a point charge on n point charges. Okay, so the concept which we have already learned, we can apply in this manner by using a practical problem. Okay.